Okay, so we're going to go ahead and move on to chapter 10. And chapter 10 is it's kind of a combination of chapter 8 and chapter 9 because we're going to be working with confidence intervals and we're going to be working with significance tests again. But now we're going to be looking at two sample data. And we're going to be looking at the differences between our two samples. So we're going to start off in 10.1 looking at the difference in proportions, and we're going to look at intervals and tests. First, we're going to take a look at the sampling distribution, and that's all we're going to do today, is what does the sampling distribution look like when I am actually calculating the difference of the two samples. So we want to make sure that the characteristic is in both population groups. The ideal strategy is to take separate random samples. So that's really important that we're taking a random sample from one group and we're going to compare those sample data. So P1 hat and P2 hat, population 1 sample, population 2 sample. And then we're going to compare the populations by doing inference about the difference P1 minus P2 between those parameters. And the statistic that estimates this difference is the difference between the sample proportions. So looking at the sampling distribution, because this is how we kind of decide our probability, what does it look like when I sample over and over and over, and how are those differences going to look like? So again, looking at that sampling distribution. So what do we know? Well, we know our two distributions are going to be normal if this is my normal condition for population 1, and then this is my normal condition for population 2. As long as both of those are normal, then the differences will be normal also. So we have to check the normal condition for both of them, which means we're going to have 4 different values that we're checking to see if they're greater than or equal to 10. Why the greater than or equal to 10? Because these are the proportions. If it was means, then we'd be looking at the sample sizes both being greater than 30. Now, what is the center of our sampling distribution? The center should be the differences between the means of the two, or the differences between the two sample proportions. So the mean of my sampling distribution will just be proportion 1 minus proportion 2. Now, what happens with our spread? Well, we can't just combine standard deviations. In fact, we spent quite a bit of time talking about if I want to put together two different distributions, what happens to that? Well, we can't combine the standard deviation, so instead we combine the variances. So those variances are really the standard deviation squared. So I square the standard deviations, I add those together, and then I square root to get the new standard deviation. And so how do I calculate the original standard deviation? Well, so remember, my original standard deviation looked like this. Oops, I need to be in pen form. So square root of P1, or P, times 1 minus P over N. So if I was to square that, that would cancel out that square root, leaving me with just that P minus times 1 minus P over N. So this is what we're getting here. This is right here the standard deviation squared, because the squaring part got rid of my square root. So that's the standard deviation squared, or the variance of my first population, or my first sample, and this is the one for my second one. And then we add those together, and then we square root to find our new standard deviation. And again, we can only use the standard deviation formulas if we meet those independent conditions. So sample problem. Suppose that 2 counselors at a school. The school has more than 2,000 students. The counselors' names are Michelle and Julie. And they independently take a random sample of 100 students from their school and record the proportion of students that did their homework last night. At the school, supposedly 70% of the students complete their homework last night. When they are finished, they find the difference in their proportions was 0.08. They were surprised to get a difference that big considering they were sampling from the same population. So let's talk about the shape, center, and spread of the standard of the sampling distribution, Michelle minus Julie, so M minus J. So our shape, we're checking to see what that shape is. Do we know it? Do we not? We suspect it's normal, so we check to see, well, what is 70% of my sample size of 100? Well, that's 70, and that is greater than or equal to 10. Okay, so now I check the remaining 30% times 100 gives me 30, which is greater than or equal to 10. So that, I've just checked the normal condition for Michelle's sample. Now Julie's should be the same. So now 0.7 times 100 equals 70, which is greater than or equal to 10. And then 0.3 times 100 equals 30, which is greater than or equal to 10. So we're good. So our shape is normal. And we've shown that it's normal by checking all of those. If you wanted to write out, well, Julie's is exact same as Michelle, so 70 is greater than or equal to 10, and 30 is greater than or equal to 10, so it's normal, you could do that. But I find it easier to just go ahead and rewrite the calculation part because it's shorter in the long run. Okay, so now what's the center? So center is calculating the center or the mean of our sampling distribution. So the mean should be 0.7 minus 0.7 because the mean for this one should be 0.7. The mean for this one should be 0.7. So when I subtract, I'm going to get a center of 0. So that mean of the sampling distribution, PM minus PJ, because these are proportions we're working with, is really just 0. And then we move on to our spread. And so to calculate our spread, we're going to go ahead and use that standard deviation formula. So the square root of 0.7 times 0.3 divided by 100, there's Julie's variance, and then 0.7 times 0.3 divided by 100. And so I'm going to calculate each one of those. And I'm going to get the square root of 0.0042. And I'm going to calculate that. And I get a standard deviation of 0.0648. So now that we have that information, we can now go to our sampling distribution and look the probability of getting two proportions that are at least 0.08 apart. So we know our differences should be about 0, and it's going to vary side to side based on that. And then each standard deviation is 0.0648. So this value is 0.0648. This value should be negative 0.0648. And then we move out 2 standard deviations. 0.0648 times 2 gives me 0.1296. And so this would be negative 0.1296. And this should look familiar because we've done this before. 3 standard deviations. So I'm going to add on another 0.0648 to that. And this is 0.1944. So what we're really looking for is what's the probability that they are at least 0.08 apart. So 0.08 in this direction would be, let's see, probably about right here. That's 0.06. So we have this. This is 0.08 apart when Michelle's is higher. Then we also have 0.08 apart when Julie's is higher. So we've got 2 of those. So this is going to be a 2 normal CDF because it's a normal curve, right? normal CDF, with a lower bound, and we can use either side. I prefer to use the positive numbers, so a lower bound of 0.08 and an upper bound of something just really, really high. I'm going to go ahead and go with 10. A standard not standard deviation, not there yet. Mean of 0, because that's what we got up here, and a standard deviation of that 0.0648. So we're going to use that to calculate the probability of getting two proportions that are at least 0.08 apart. So let's see, 0.08, 0, 0.0648. And we get a probability, I forgot to times by 2, of 0.21699. So that's a pretty high probability. Should the counselors been surprised to get a difference this big? No. There is a 21.7% chance of getting a difference of 0.08 or greater in the two proportions. Okay, so that's what we're going to work on in class. We'll see you next time.